Yeah, welcome to class. This is the third class, and we are going to be looking at the application area, the the application of Python in electrical engineering. What we've actually dealt with last in the first and second class was we looked at the introduction and we looked at the general application of Python in different areas of life, like in web application, data analysis, automation, embedded system, many other things like that. But here now we are going to be looking at Python as it actually correlates, as it actually specifies, as it is actually being used in for electrical students. So let's go back to our notes and continue from where we started. So application area, we say Python is widely used in electrical and electronics engineering because it simplifies complex calculation, supports simulation, and enables automation of engineering systems. So you must understand this. You must see different areas of application of Python in electrical. It is being applied for circuit analysis and simulation. These are some of the libraries that are being used. You will see these libraries by the time we are running the program, and we want to run a sample of this circuit analysis and simulation so that we'll be able to see how it actually look like. So I will open the environment of Python. Yeah. Now I know some of you will say, "What? Where is this? This is an online Python base which you have access to. Don't worry. By the time you get to the practical side, you will understand." And there's some code that I copied somewhere, which I'm going to be running here now. For the signal processing, if you look at this circuit analysis and simulation using Python. So I'm going to copy this. So I will explain to you how you will understand this, how you'll be able to use this so that you get it. Because if you look at this, import required library. This is the library we are going to be using, the NumPy library and the matplotlib libraries. So these are parameters we are going to. So anytime you see this hash, it's telling you that what is in the front is comment. It's not going to be run in the program. It's just information for you to read. So all this hash, that means all this one they are not going to run. This is what we run. All this one they are not going to run. Can you see all this hash they are not going to run? All this till this place we're not going to run. This is what we run. All this solve node whatever they are not going to run. That is what we run. So we are going to copy everything. I'm going to copy it one after the other. That which is going to be run. That is what I'm going to copy. I will copy the title so that we have the understand. But don't let me copy the title. I'll just copy what we are going to be running. It's a simple circuit analysis and simulation using Python. So let's put it here and just paste it. You click display to run it. This we actually install all the libraries that we are going to be using. So by the time it's finished installing the library, you will see it will check this place. It will tick it to tell you that yes, it is certified. But if can you see it has checked it, that means it has installed it. So the next code is to come here, just put your mouse here, then click the code again. So you are going to go and copy the code that's going to run. Can you see? I didn't copy where the hash is. I only copy where there is no hash. So I'm going to copy this one and place it here. Then run it again to let it understand the voltage source is this and to know the resistance in ohms. All these the different resistance we are going to be using. Then click this one again. I'm not going to copy that, so I'm going to copy this. Again, this is conductance value. So we are putting the conductance value there again. We supply the voltage source, we supply the resistor, we supply the conductance value. So again, we are going to look at the current versus the resistance. So we are going to run it again. Paste, run. We are supplying the value. Can you see there is an error here now? Can you see? Current calculation. So there is an error here. So what you just need to do is just to click this, explain this error. It will show at this right hand side. It will explain the error for us because we are online. So automatically it will explain the error. If it's not online, that means we have to debug. That is where debug comes in. You have to check the analysis and see what can be the error. But with the use of this, it's going to check it for us and check and do the correction. So the code is throwing the name error blah blah blah. So it has corrected it here. So you now click accept. Once you click accept, then we'll be able to go back and check. Can you see v node equals to g? So let's compare this with this. Can you see it's using r1 here, it's using g1 g2 here. So it has corrected the code. So let's tell it to print the value for this now. So copy. So we go there again. This is just a sample. I'm showing the application area where we are talking about. What we are dealing with now is area of application. So can you see print circuit analysis? So source voltage is 10 volt, node voltage is 5.6, the current is this, the current through the first one is this, the current through the second resistance, the current through the third resistance. So we are still going to, so we are looking at the power dissipation. So we are going to copy. You can copy everything, but we just need to run it one after the other so that we have the understanding. If you copy everything and just paste, you won't know how it actually runs. Can you see? It won't run this, don't forget. I just need to paste it. I didn't paste it in. So okay, I put it here, but I didn't put it here because we don't understand. But because it is necessary you put them there so that anybody that is reading this will be able to see what and what this means, what this means, what this means. So it is good to put the comments there. So I'm running this one now. This is the power dissipation, and it has shown using this calculation, this formula here to do the calculation. Then again, I'm going to copy the comment side. Plot voltage and current. We are telling it to plot the voltage and current graph now. So let's see how it's going to look like. So by the time you click it, it's going to check and check. Then it has take it plot voltage and show plot current show. Can you see? We told it to plot, but it has not show. But this is where it is your plot dot show. So automatically, by the time you finish the plotting, it's going to show what we are talking about. Can you see? This is the bar we are talking about. This is the current through each resistor. That shows the current. This is what we run, and this is the result that is shown here. So that is that. So again, I want to tell you to plot power dissipation also. This show, it is what we tell it to show to display what we actually running. So we are pasting it again. Click show, then it will run again and show the power dissipation in each of the resistors. So this is how to actually run use the Python. You will understand it better as we move forward because it will actually help you in data analysis and many other things like that. But I won't be telling you that. I won't be showing you that. You need to go and develop yourself or on that. You understand? But we are going to strictly go through we are strictly going to follow what we need to follow. So let's go back to the note. So that is for circuit analysis and simulation. So another area of application in electrical engineering is signal processing. Python helps in analyzing and manipulating electrical signal such as audio, voltage, and communication signal. This one is actually, there is something that we are going to run this one in practical area so we understand this better. Then in control system engineering, of course, there are some other code that can run, but I'm just trying to look at the time. I want you to copy your note and I want you to follow this. Once you have the basic understanding of this, you will understand, you'll be able to run this thing very well. I will show you step by step on how to run that. Even this platform that we are in, you are going to see how we are going to actually run it. So let's go to the next one. We are looking at the area of application as it applies to electrical engineering. So next one is the power system analysis. Python is also applied in power system analysis. It helps in analyzing electrical power generation, transmission, and distribution systems. There are some libraries that we use also. Of course, there are some libraries here that is common in others also. I think this is signal processing. The NumPy library is here, and if you look at the power system analysis, the NumPy library too is there. So it doesn't matter that that means the library can function in different areas, different applications. Now it's been applied also in embedded system and Internet of a Thing. And we have this library, micro Python, CircuitPython, this Raspberry Pi, GPIO. So again, is used in data acquisition and instrumentation. We are talking about the area of application as it applies to electronics engineering. It's applied in machine learning in electrical engineering, and these are the libraries. It's for use for automation and testing also. The libraries here is Selenium, PyTest, PyVisa. and many other things like that. So in electrical electronics engineering, Python serves as a powerful tool for Python serves as a useful tools for simulation, automation, data analysis, embedded system, and intelligent system design, making engineering tasks faster, more accurate, and more efficient. So I hope you understand what we're actually talking about Python. So what we just look at now is the area of application as is related to electrical engineering. We've already looked at the area, the general area of application as related to the general world. So then we look at the area of application as related to electrical engineering. So let's look at the features of Python. Simple syntax. Python uses clear and readable command that makes programming easier to learn and understand. So let me just change this thing back to, I think it is in color format. I hope I will be able to, I don't know. So we used to be in color format, I was the one that changed it to black and white like this. So now, if you look at this area of application, simple syntax, interpreted language, the features of Python: easy, expressive, cohesive, free and open source, high level, portable, object-oriented, extensible, embeddable, interpreted, large standard library, GUI programming, dynamically typed. So from this image, you can easily see 12 common features of Python. So please take note of that. Of course, it is very necessary that you take note of that. These 12 common features of Python. So we still have them listed here: high-level language, portability. But I think this image alone has actually captured everything, so that I'll be able to see it and read it. I won't be asking you to be drawing this. I will only ask you what are the features of Python. So you must be able to list at least 5 to 10 features of Python for me. So I think the application area as it applies to electrical engineering and the feature of Python, I think is okay here. Then the next class we are going to meet and continue, so that we make the class bulky and look tired. What do you call it now? Bulky and bore. So thank you for now. So we'll meet in the next class. Please don't forget to drop your matric number, as that is where I'll be taking the what do you call an attendance form. Of course, I'll be dropping some links again where you answer your question. I'll be sending you some of the questions you answer. You answer it on this, I'll be able to mark it. Thank you and take care. Bye.